Black holes, where the universe breaks its own rules. Imagine a place in the universe where time slows down, where space bends, and where light itself cannot escape. This is not science fiction. This is real. These places are called black holes, the most extreme objects ever discovered. For a long time, scientists believed black holes were impossible. Even Albert Einstein thought they were just a mathematical trick. But today, we know something shocking. Almost every galaxy in the universe has a black hole at its center, including our own. Right now, in the heart of the Milky Way, a supermassive black hole called Sagittarius A star is spinning silently, with a mass 4 million times greater than our Sun. But what exactly is a black hole? How are they born? And what would really happen if you fell into one? The birth of a black hole. Black holes are created when massive stars die. Not ordinary stars, but giants many times larger than our Sun. When such a star runs out of fuel, it can no longer hold itself up against its own gravity. The core collapses. In a fraction of a second, the star explodes in a violent supernova, one of the most powerful events in the universe. But sometimes, the collapse doesn't stop. Gravity wins. All that mass is squeezed into a point so small, so dense, that space itself breaks, and a black hole is born. Not all black holes are the same. There are three main types of black holes. Stellar black holes, formed from collapsed stars. They are only a few times more massive than the Sun. Supermassive black holes, millions or even billions of times heavier than the Sun. They live at the centers of galaxies and control the motion of entire star systems. And then there are rogue black holes, wandering alone through space, invisible, silent, undetectable, unless they pass close to something. The point of no return. Every black hole has a boundary called the event horizon. This is the point of no return. Once anything crosses it, matter, energy, even light, it can never escape. From the outside, something strange happens. If you watched a person fall toward a black hole, you would never see them actually cross the event horizon. They would appear to slow down, freeze in place, and fade into darkness. But for the person falling in, everything would feel normal. At first. What happens if you fall into a black hole? As you approach, gravity becomes uneven. Your feet are pulled harder than your head. This effect is called spaghettification. Your body would stretch, longer and thinner like spaghetti. Time would also change. To the outside universe, you would appear frozen. But for you, time would continue normally. Seconds would pass, then minutes. And then, physics as we know it would stop making sense. No one knows what lies beyond the event horizon. Some theories suggest a singularity, a point of infinite density. Others suggest wormholes or even connections to other universes. But the truth is simple. No information can ever come back. Black holes are not cosmic vacuums. Despite popular belief, black holes do not suck everything in. If the Sun were replaced by a black hole of the same mass, Earth would continue orbiting normally. Black holes only consume what comes very close. Most of the time, they are quiet, invisible, only revealing themselves when they feed. The brightest objects in the universe. When matter falls toward a black hole, it doesn't fall straight in. It forms a spinning disk called an accretion disk. Friction heats this disk to millions of degrees. It becomes so bright that it can outshine entire galaxies. Some black holes also produce relativistic jets, streams of energy shooting out at nearly the speed of light. These jets can stretch for thousands of light years. They shape galaxies, they affect star formation, they influence the structure of the universe itself. We have seen a black hole. In 2019, humanity saw something historic. For the first time ever, scientists captured an image of a black hole, a dark shadow surrounded by glowing light. This was not an illustration, not a simulation. It was real. That image confirmed something profound. Einstein was right. Black holes and the fate of the universe. Black holes may survive longer than anything else. Even stars will die, galaxies will fade, but black holes will remain. And slowly, over unimaginable timescales, they will evaporate through a process called Hawking radiation. Trillion by trillion years from now, even black holes will disappear, leaving behind a cold, dark universe. Why black holes matter? Black holes are not just destroyers, they are architects. They shape galaxies, they control cosmic evolution, they test the limits of reality. By studying them, we learn not only about the universe, but about the nature of time, space, and existence itself. Final thought. Somewhere out there, billions of black holes drift through the darkness, silent, invisible, powerful beyond imagination. They remind us of one thing. The universe is far stranger and far more beautiful than we ever imagined.